So Chapter 5 is the mathematics of finance, and we're going to start with simple interest and discount, which are related. And I think an interesting way of thinking about interest is as the rental fee for using someone else's money. So you either get to collect the rental fee for letting someone else use your money, or you're paying somebody the rental fee if you're using someone else's money. Interest on loans of a year or less is often calculated just using simple interest. This would be something like, my son needed to borrow $100 from me to help out with prom expenses. So I said, well, that's fine. And then 2 months from now, you need to pay me back $105 or a 5% interest rate. So that is simple interest where it's just some percentage of the amount lent. So the beginning amount borrowed or deposited is usually called the principal. And principal can also be thought of as present value. So in fact, in your book, they use the symbol PV as present value. It's one number. So even though they're using 2 letters for it, it's a single number. Interest rates usually are quoted as a percentage per year. So you must convert to a decimal before you ever use it in interest calculations. So for simple interest, the time is in years, and you would say the interest amount is the principal or the present value times the interest rate as a decimal times t in years. So 6 months would be t is 1/2 or 0.5. So make sure you're always working in years. So let's find the interest on an amount of $5,160. So that's the present value. The rate is 7.1%. So we're going to convert that to the decimal of 0.071. And then it's for 58 days. So that's 58 out of 365. That's what fraction of a year that is. So then you multiply using your calculator and you should get about 58.22, and we're always going to round to the nearest penny unless instructed otherwise. And we also assume a 365-day year. Way back before computers, often accountants used a 360-day year and 30-day months just because it made computations easier. But we have calculators and computers now to do all that, so pretty much we've standardized to a 365-day year. So for corporate bonds, they're a special case where usually investors are paid semi-annually, twice each year, half of the amount that they would have been paid after a full year. So you calculate the interest as if it was for only half of a year. So the interest on this bond for $4,500 bond at 2.134%, so we need to change that to a decimal, 0.02134, and it's for half of a year because we're figuring it out for a semi-annual basis. So you're going to get 4802 each 6 months. So that's rounded off. And the answer in the back of your book, they rounded here and then multiplied this by 14 6-month periods to get their answer of 672.28. It turns out a few pennies off if you instead come back to the interest formula and put a 7 in for 7 years. So I'll go by how you calculated it, just make it clear how you calculated it. Okay, future value is, suppose you lend out some money and you collect it back with interest, then the amount that you collect is called the future value. So again, even though this has 2 letters, it's representing one number. So if I lent out $100 and I collected $5 of interest, my future value is $105. But because of the way interest was calculated, where interest was PV times R times T, we can factor out the PV and see that this is another version of the formula that's exactly equivalent, just whichever one you prefer to use. So let's use the second one to figure out the future value for this question. I start out with a $3,475 loan. I'm going to have 1 plus my interest rate converted to a decimal is 0.075, and my time is 1/2 of a year, or 6 months. So I'm going to get about 3605.31. Don't forget your dollar signs on all of these problems with dollars. So if we wanted to solve this formula for the present value, we would divide both sides by 1 plus RT. So if you're trying to figure out what amount do I need now to end up with a particular future value, this is the equation that you would use. It's copied again here just so it's close to the problem we're going to use it for. So I want to find what's the present value I need, say, to invest in a savings account if the future value I want is $29,764, and let's do it for 10 months. Not sure why I put 10 days, but 1 plus, and then your interest rate is 0.072 converted to a decimal. And then for 10 months, you're going to have 10/12ths of a year. So the amount that you need to invest now is $28,079.25 in order to have $29,764 after 10 months. It's not a very long time period to have your money collecting interest, so you need almost the whole amount to start with, because it's not going to gain that much interest. Okay, so then let's talk about discount, because this comes up quite often in business situations where the idea is that, say you have an invoice and somebody does owe you money and they're going to pay you $10,000 2 months from now, but you really need the money now. Well, there are businesses out there that will lend you most of that money, but they'll take some up front and they'll only give you, say, 9,000 of it, and then at the end of the 2 months they'll collect the entire 10,000. So the loan is considered to be a $10,000 loan, but you don't receive the whole amount. You receive a discounted amount. So the two types we've talked about so far, money's borrowed, simple interest is charged, and the amount borrowed plus the interest is paid back, and the corporate bonds, those two are both scenarios where you receive the principal and pay back the principal plus the interest. So the discount method is the other method where they subtract the interest from the original amount, but then you pay back the entire amount. So this is called a simple discount loan. And paycheck loans at those paycheck lending places are handled this way. So the borrower receives the principal less the interest, but pays back the principal. So a really common example of this is U.S. Treasury bills. So they're sold at a rate that's a discount from their face value, but then the government pays back the face amount. So let's look at a T-bill where it's a $12,750 T-bill. So my discount amount is calculated the exact same way you would calculate interest. So 12,750 times the interest rate converted to a decimal, 0.0023, times 1 month, so that's 1/12th of a year. And that gives me about $2.44. So then the price you pay is the face value less the discount. So that's going to be the 12,750 minus the 244, or 12,747.56. So that's the price of the T-bill. And then they want us to calculate the actual interest amount paid by the Treasury, and I find this kind of interesting because this is saying if this was simple interest of $2.44 that you got from lending 12,747.56, so sometimes the discount rate is a little misleading. And if you actually figure out the interest rate, so you would multiply both sides. That was a 12, right? Multiply both sides by 12. And then divide both sides by the 12,747.56. So see how I'm not dividing by the face amount? I'm dividing by the price. So then I get that R is about 0.002297, which I can convert to 0.2297%. So you can see that's actually a little less than the 0.23% that's quoted as a discount rate. So that's all there is in section 5.1. Enjoy the nice short homework.